Okay, so these are notes for page 15. To show that atoms we start with are conserved in a chemical reaction, we need to make sure that the reaction is balanced. A balanced equation shows that there is the same number of each atom on the reactant side and the product side. So whatever you put in to get the reaction going needs to be the same amount that's coming out. So this is key right here. So when balancing an equation, we can change the coefficient. We can change the coefficient, but we cannot change the compounds that are present, so we cannot add another compound, or we cannot change the subscript. So these are coefficients. This is a coefficient. If there's nothing in front of a number, it's a coefficient. It's 1, right? Nothing in front of a number, it's 1, and then this is a coefficient of 2. So 1, 2, 1, 2. This is coefficient. Subscript is actually what the compound is made out of. So for example, H2O, the 2 is a subscript, and those you cannot change. So the little number over here cannot be changed. Alright, so let's look at the first example to see whether or not this equation is balanced. So the way we're going to do, we're going to separate the product from the reactant. So right here, just create a line separating them. And then we're going to look at what elements are present. So I have carbon present right here, and then I have a carbon present in a product side. I have a hydrogen present, and then I have oxygen present. So my reactants have carbon, hydrogen, and oxygen. Therefore, my products must have carbon, hydrogen, and oxygen, and actually they need to be the same amount. So I have 1 carbon, so I have the coefficient here 1, and there's no subscript, which means 1. I have 1 carbon. On this side, again, 1 coefficient, no subscript, 1. I have hydrogens. I have 4 hydrogens. You see the little subscript over here. This subscript only applies to hydrogen. Now I have a subscript over here just for hydrogen that says 2, but there's a 2 in front of it, so it becomes 2 times 2. So I have 4 hydrogens on this side as well. Lastly is oxygen. So I have O2, right? So 2 oxygens, but I have 2 in front of here, so it means it's 2 times 2, which is also 4. Here I have 2 times 1, which means 2. However, there's another oxygen here, so 1 times 2, 2. So I have 2 oxygens here and 2 oxygens here, which makes it 4. So let's see if this equation is balanced. So 1 carbon on each side, great. 4 hydrogens on each side, and then 4 oxygens on each side. So this equation is balanced. So the energy, so not energy, but the conservation of mass says that whatever reactants are present, the products must be exactly the same. So 1 carbon on each side, 4 hydrogens on each side, and 4 oxygens on each side. Alright, example number 2. Again, line. Find what elements are present. You have hydrogen and you have oxygen. On this side, you have hydrogen and you have oxygen. Now let's find out how many of each are present. You have 2 hydrogens, In here you have 4 hydrogens. How so? You have 2 times 2. So you have 4 hydrogens. In here you have 2 oxygens. And in here you have 2 oxygens. 2 times 1. Remember, if there is no subscript, it means that there is 1. So you have 2 oxygens. Now let's look to see if our equation is balanced. Oxygen, you have 2 on each side, so this is balanced. However, hydrogen is not balanced. The reactants have 2 hydrogens, the products have 4 hydrogens. So in order to fix this, what you do is you just put a 2 in front of here, because now you know that 2 times 2 equals 4, and that's the number you need. So now scratch there and make it 4. So now this equation is balanced. As you're going to see, you're going to practice a lot with the balancing equation. You're going to see those dashed lines just indicating how you should balance the equation. So right here, there was an indication that a number needed to be present here. A lot of times, if the line is present and is already balanced, you can just put a 1. Okay, but this dashed line just means that you should put a coefficient in there. Alright, that's it.